Hello, everyone, and welcome to another great episode of Hive Live. I'm Alex Netty, and today you're going to hear about one of the hottest topics in the news, blockchain. While you may not know what blockchain technology is, you've likely heard about things like Bitcoin, Ethereum, or even Dogecoin. The tech behind these currency alternatives could be a game changer for the world at large. But ultimately, what is blockchain technology? And what does that mean for cybersecurity? How can blockchain help or possibly even hinder when it comes to securing our data and our devices? Well, to help break it all down, joining me today is a guru of all things blockchain, crypto, and cybersecurity, Andrew Bradley. Andrew is a cybersecurity specialist who previously led PwC's public sector blockchain pursuits. He began his journey in blockchain in 2015 after being strong armed by a friend into buying his first Bitcoin, and soon after became obsessed with the tech that underpins the global P2P electronic cash market. Ultimately, this led him to Ethereum in 2016. Since then, he has been a community contributor, supporting open source Ethereum development, advising Ethereum based projects, contributing to EthHub, and an open educational and knowledge sharing resource for anyone interested in or building on Ethereum. And more recently, experimenting in the world of decentralized finance and non fungible tokens or NFTs. Bradel, welcome.
Hey, thanks for having me, Alex. I appreciate you guys letting me get on here and talk to you a little bit about, what seems like a crazy pursuit these days, but it's getting a little bit more mainstream. So I appreciate you guys giving me the little venue here.
Now, Bradel, or rather, Andrew and I have known each other for quite some time, and his
Yep.
pursuits into cryptocurrency I have followed closely. He and I have worked closely in the realm of cybersecurity for a number of years, so I'm excited to have this talk and educate myself a little bit more around this.
Sure.
I think the main place to start here, Andrew, ultimately is what is blockchain technology, and what does that mean?
So first, if I keep looking down here, it's because my screen is down here and my camera's up there, and I tried to move it before and it looked even more awkward. So I apologize for not making direct eye contact. But to really start with blockchain technology, you got to go back to Bitcoin and Satoshi Nakamoto. So 2008, the white paper, the initial draft of the white paper was originally released, and then 2009 it was the first implementation of the Bitcoin client was released on, I think, like SourceForge of all places. I don't know if you guys ever used SourceForge, but it's an old school software distribution network. Back dating back all the way to the beginning of the dot-com era, and so it was released on there, and a bunch of cypherpunks kind of found it and started working with it, and working with Satoshi to kind of flesh out some of the early issues and bugs, and get it into a state much like it is today, because Bitcoin is pretty much for the most part unchanged since its foundings, except for a couple of improvements here and there. But basically, a blockchain, you might want to just think of it kind of like a distributed, decentralized database. It's like a write once database, or a linked list where the rules of the network are governed by a decentralized consensus of nodes. So basically, people running software on their systems, the software is the coded rules, and basically the work that they do to create blocks, basically brute forcing a hash to create blocks, is what ultimately provides both the security for the network and also enforces those consensus rules. So things like the 21 million cap in Bitcoin, the execution of smart contracts in Ethereum. So that's basically what what a blockchain is. It's just a giant decentralized distributed database with shared rule sets and a group of basically watchmen who are incentivized to secure it. Um, but yeah, I mean, it's a very, blockchains have evolved since 2009, 2010, since 2016, 15, when Ethereum launched. You've got all different types of blockchains now with high throughput chains, lower security and decentralization chains. And you've got private blockchains versus the public blockchains like Bitcoin and Ethereum. So you've kind of got like this budding ecosystem of blockchain technology emerging right in front of our very faces, our eyes right now. Um, I mean, it's a little bit of a still of a like a buzzword for people. Everybody likes the word blockchain these days, although some are better than others, some are more decentralized than others. What it really boils down to is what we can build with these networks and the interesting kind of incentive markets and games that come along with them. A lot of the interest around blockchain was kind of spawned around the ICO era in 2017, where everybody got these fancy tokens and all these coins and wanted to kind of make a lot of money off them. So you saw things like a Dentacoin or a, I don't know, like a Guppy for a peer-to-peer matchmaking network on a blockchain and stuff that didn't really necessarily make sense. And now we're kind of seeing the maturation of the market where these are really primarily money markets or capital markets and places where value should be settled, not like maybe not supply chain, maybe not some of these provenance use cases that we thought. But absolutely, there's ways we can kind of shoehorn some of those things in and benefit from some of the security and the secure data layer that a blockchain might provide.
Well, and
But yeah,
for those who
that's
don't know,
yeah,
Andrew mentioned ICOs, those initial coin offerings,
yep.
which I think
Sorry.
takes us kind of to the no, you're fine. It takes us to kind of the starting place for one of the
Yep.
maybe most well-known uses of blockchain, which is cryptocurrencies.
Right. Yep.
So ultimately, yeah, what are cryptocurrencies and how do they leverage that public blockchain technology?
Absolutely. So you've kind of you've got this scenario where cryptocurrency had a very specific purpose in the initial onset of public blockchain networks. So Bitcoin and Ethereum used their cryptocurrencies, one, to incentivize security. So a cryptocurrency was built into the network to reward the miners, or if it's a proof of stake network, the validators, to produce blocks and do it honestly. So that's the first mechanism, or the first function of the cryptocurrency in the blockchain, is to provide that incentive for security. Initially they weren't really listed on exchanges. Some exchanges came around early. Mount Gox or MT Gox, Magic the Gathering online exchange, came around and well, they're most famous for a big hack that happened, but listed these things and initially gave them value. So people, that's what really drove the mining and the staking to the blockchains, is this economic incentive to crunch numbers and solve hash puzzles to validate and earn these rewards. So it's that crypto economic incentive that actually secures these networks, and that's based on the cryptocurrency. The second part of that is actually that the cryptocurrency is sort of a Sybil/spam control for being able to use the network. So one of the things that you have to do in Bitcoin with every transaction is you have to pay a fee. The fee goes to the miner on top of the block reward, which is the new issuance of Bitcoin, to those miners for doing that work. So the fee goes to them, but it also prevents people from being able to just spam transactions on the network, fill up blocks, and basically denial of service attack the network. So it kind of gives you that incentive, where it costs, if you want to spam attack the network, it's going to cost you a significant amount of money. And the more you spam attack it, the more it's going to cost you, because it's a fee market. So you'll consistently fill up the blocks, and then you'll bid up the fees and have to pay more and more and more to be able to get included in a block anyway. So it's a really clever. The cryptocurrencies are actually really clever utility tokens that are built into these networks. And now they've got all sorts of speculative value now that they're listed on centralized exchanges, but primarily they're required for those two use cases.
Interesting, and you call it a
Mhm.
network as a whole. So, I mean, is that
Yep.
how does that maybe vary traditionally a blockchain network versus maybe in the
Yeah.
world of IT a traditional network?
Well, it doesn't differ all too much actually. So in a traditional, like intranet or internet, you've got nodes, basically your routers, your DHCP servers, your switches, your gateways. Basically, you've got all these nodes that are connected, that are facilitating TCP/IP and IP interactions on an intranet or the internet. Um, Blockchain is very similar. You've got a distributed network of nodes run by anybody around the world who has the resources that can run a blockchain node. Those nodes communicate with each other, and they enforce the rules of the blockchain on every transaction and every block that's built. So basically, it's kind of similar to an internet, in that instead of routing rules, you have transaction rules and block production rules that these nodes are basically communicating over a peer-to-peer communication network to enforce. So it relies on the internet, but it mimics a lot of the same peer-to-peer elements of network communication that the internet has itself. So if you think about like the network layer or the transport layer, you can kind of think of a blockchain as like the transport layer for transactions and money. So the
Mhm.
cryptocurrency itself may be like a packet. Um, a cryptocurrency transaction on a blockchain may be like kind of like transferring a packet on the internet. But instead of being routed by like one or two nodes, it's processed by all the nodes in the network, which provides that security for the cryptocurrency and the transaction itself.
Do you think that's simpler for non-IT people to get into the blockchain space because it's maybe not as complicated in terms of the routing and the overall
Right. Yep.
network posture, or do you think that makes it more difficult, or how does that look?
Well, actually, I think if you asked a lot of people how the internet works, a lot of people wouldn't really be able to tell you how it works. And there's not like a whole, there's not a very simple explanation
It's a
associated with,
series of tubes. Everybody
yeah,
knows
exactly. There's just like there's a couple of copper wires outside that just connect to everybody's houses, and
it.
then there's a network running on top of that somehow. So people don't fundamentally understand like the role of an ISP. They don't understand the role of like your modem or a DHCP server or DNS. They don't really understand those things, and those are kind of nebulous concepts to your general person. People in IT, they might absolutely understand that. But for the concept of a blockchain, all you really need to know is that there's people running nodes, there's people non-mining nodes and mining nodes. There's people running these nodes. The miners produce blocks. The non-mining full nodes or validating nodes verify the rules are enforced in those blocks and in the transactions. Otherwise, they'll reject them, and then they broadcast those across the network to each other. And you don't actually have to rely on any single one of those nodes for trust because you're downloading and verifying all that data as it's coming in from the peers. And that's basically the consensus mechanism that backs a blockchain. So you don't necessarily have to understand these concepts. You just have to know that there's nodes, they do their role, they enforce the security, they validate, and then beyond that, I don't have to trust that there's any single person, single entity, single ISP, router, DNS provider that I have to rely on because it's a decentralized network. And that's kind of the beauty of it. It's a little bit simpler by design than even the internet is, despite the fact that it requires the internet to run. Yeah.
Well, you said the magic word
Hmm.
security.
Yep.
So let's talk a little bit about security within blockchains and
Sure.
cryptocurrencies as a whole.
Yep.
What is kind of the overall security posture of blockchain tech? What does it do maybe better than our traditional networks? Where does it fall
Yeah.
short?
Yeah, it's a little bit, security in blockchains is a little bit different than your conventional security in networks. I mean, fault tolerance is still a concept that exists in any distributed network, but when you're talking about like an internal intranet, or you're talking about the internet, it's a little bit of a different type of security that we're talking about. So you're not basically worried about securing nodes, securing packets. You're more worried about the type of attacks or the type of faults that can happen that can
Mm,
basically take the transactional network down. Um, and obviously the biggest problem being a double spend attack, something where somebody is able to replay a transaction or double spend the same balance or the same coins, cryptocurrency tokens, so to speak, without any sort of validation or recoverability from the counterparty. And basically, the way that works in blockchains is it's twofold. So you have a Sybil control, which is proof of work. So blockchains use Sybil controls like proof of work or proof of stake, and those sit on top of consensus mechanisms. The consensus mechanism in Bitcoin is Nakamoto consensus, and currently in Ethereum is Nakamoto consensus. In Ethereum proof of stake, the consensus is called Gasper, which is Casper and another Byzantine fault tolerant consensus mechanism baked in. But basically, the way that security works here is you have the crypto economic incentives of the token providing the miners or the stakers who are providing that Sybil control, which means you can't spin up like a random node to join the network and mine or create blocks in proof of stake.
mm,
Because if you could do that, you could just spin up a billion nodes or a million nodes and 51%, the theoretical 51% attack a network. You could attack the network or bring it down or censor blocks. So that proof of work creates a cost associated with that, with the creation of a block production node, and participating in the chain consensus. So basically, what happens is based on those crypto economic incentives, people are incentivized to act honestly, despite the fact that nobody knows each other. There are these there's huge mining farms out in China. There's huge staking pools in the United States for exchanges. Nobody knows each other. There's no like legal agreements. There's no contracting or anything like that. But you don't have to worry about that because the trust minimization of the protocol and these crypto economic incentives incentivize people or incentivize these groups to basically process the transactions honestly, don't roll back the chain, don't change the rules, don't double spend. Like if you get 51% of the hash rate, it may not be actually economically, um, I guess, economically beneficial for you to double spend or roll back the chain, despite having that control, because then you lose out on the potential future rewards. Or the networks have a social layer, obviously, where people can coordinate, push a hard fork through, which is basically a non-backwards compatible change to the network, and kick you off of it, either miners or stakers. So there's a lot of incentives, and so basically the security of a blockchain is totally built around like economic incentives, whereas like things in computer networking are built more around like practical security and operational security considerations. Securing your perimeter firewalls, your defense and depth type stuff, host and endpoint protection and hardening, and virus protection, things of that nature that kind of prevent actors from coming in, because there is such little economic cost to attacking something in a traditional network, that's the type of security we are able to rely on in in regular networks. A blockchain can't really rely on that type of security, so it has this crypto economic security that basically backs everything. So
Well,
it's a little bit different.
I do like a good threat vector, and I think that
Yep.
51% attack is a good example of that, right?
Yep.
Where if you can command the majority of the blockchain, you could potentially command, well, the blockchain.
Yep. As
And
long as it
so,
makes
yeah,
economic sense for you. Yeah.
as long as it makes economic sense. And I think
Hmm.
that's the big part in this, right?
Right.
When we
Yep.
look at that disparity between what does it take to hack a traditional network versus maybe the blockchain,
Right.
traditional network doesn't have that same kind of decentralization. And it's much
Right.
easier, usually, as we've seen
Yep.
very frequently, to get into it. So,
Yep, they're very resilient, and that's one of the things. Like blockchains are far more resilient than any traditional internet or network or payments network that we see now that is centrally controlled. So before I mentioned like a private blockchain where you might have one entity running all the nodes, or a permissioned like conglomerate chain where it's a group of a federation or a group of members or a membership group that is running the blockchain. So those blockchains have different incentives and different and like either reputational or legal aspects to them. So that's really what's backing like a private or a permission blockchain versus a public blockchain, which is totally trust minimized and based on purely economic incentives. Um, some people think that's not the best way to go with a system or a network, especially if you're particularly egalitarian or trying to be egalitarian and you don't want things to centralize to the haves versus the have-nots. But again, it's one way to secure a network, especially a decentralized network, versus your standard trust anchored security models.
we'll come back to that in a minute. I
Sure.
suppose, from obviously we talked a little bit about cryptocurrencies as a whole. What else could people leverage blockchain technology for? What other use cases are there out there today as they exist or have been, thought about?
Yeah, I mean, cryptocurrencies are kind of like I mean, they're basically the baked in functionality, right? If you just wanted a simple payments network, the cryptocurrency itself can function as the medium of exchange, or the unit of account inside that blockchain. Um, so payments are a natural use case, and we'll hear things like digital gold because Bitcoin's got a finite supply. So like a traditional investment or commodity, where you just kind of hold on to it, is like a popular use case. But there's definitely more things you can do with blockchain than just kind of the simple stuff that you get at the very top level of looking at these. For one, right now we're seeing a lot of kind of like explosive use cases developing on Ethereum and a couple of other competitors that have released to market recently. What's in around what's called decentralized finance. So we're seeing, because of Ethereum's smart contracting functionality, which differentiates it from Bitcoin. Bitcoin's a very simplistic network, simple scripting language, and it supports a very basic smart contract functionality to the point of maybe like a multi-signature, or some other kind of simple contracts. Ethereum has stateful contracts, and its scripting language and virtual machine enable it to do definitely more complex conditional and logic type contracts. So you can basically build little tiny computer programs on Ethereum based on the functions that are available. And similarly, you can do that with some of the other newer, more modern chains that are coming out, that offer kind of like the throughput increase over the centralization aspect. So what we're seeing now is this thing called decentralized finance, where people are building all sorts of derivative markets with tokens, liquidity pooling and mining, basically. So people provide it. People basically these tokens are created for a singular purpose of governing some platform or some application built on Ethereum or whatnot, and they're providing these tokens to these contracts as liquidity providers, and they're earning yield on them or interest. And it's kind of inviting all these weird fringe financial use cases that are kind of sucking capital away from Wall Street and the traditional market. And those are kind of like the fringe use cases we're seeing now. But if we're talking about like more security aligned use cases, like what can we use a blockchain for in the security realm? Well, I have to first go to like identity. And I don't mean like, like adjudication of who is who, because that's a very subjective process that requires like some sort of centralized authority to say, Alex Netty is Alex Netty or Andrew Bradley is Andrew Bradley. The person that's on your license is who you say you are. So that requires some subjectivity and a centralized authority. But what we're talking about more with identity is like single sign-on capabilities almost.
Mhm.
So you in Ethereum, in Bitcoin, you are basically given you're not given. When you're using the network, you are using a wallet, right? So this is your cryptocurrency wallet. It's basically a public address. So if you're familiar with public key infrastructure, your wallet address is just a public address, and you manage the private key if you're doing things non-custodially or self-sovereignly. You manage the private key for that public key, and so you are able to authenticate for that address to say that it is you, or that this transaction is signed by you. So we can see in like Ethereum wallets, we're already using this for a lot of what I mentioned before, a lot of the DeFi interactions. You go to a website for one of these DeFi apps, and you are basically taking your Ethereum wallet, signing a transaction to prove that you own this address, and authorizing that address to interact with the smart contract, or the smart contract to interact with your address. So there's other use cases where we can take kind of this public PKI infrastructure and use it to support kind of single sign-on and authentication. You would just have to build some layer on top of that for actual identity verification.
Mhm.
And this is something that, like there's a big initiative called ID 2020. They've been working on it. Microsoft is part of that, and they've been working with both the Bitcoin and the Ethereum blockchain to flesh out some, big public single sign-on PKI-based authentication systems, where we're using basically your crypto wallet to verify yourself to services. Think of like the Apple, the Apple login or the Google login or the Facebook login. Instead of those services, you have a public decentralized network with some identity attester, or maybe crowdsourced identity attestation, saying that if you own this public key, or you own the private key to that public key and sign this message, you are this person, and they will authenticate you then. So there's very creative use cases we have in the future for things like identity. One of the interesting projects in that space is called Uport. I think it was previously this company called Consensus affiliated, but I think maybe they've spun out by now. Uport is a pretty cool project in that realm. There's and sorry if I'm rambling on. Feel free to totally just cut me off, because I could talk about this stuff forever. So if you have a question in there, just feel free to
Well,
hop
you
in.
bring up something interesting,
Yeah.
and I think it relates to those who are holding coins, but also
Yep.
potentially from an identity perspective, right? There's kind of this change, and we've struggled with this within the cybersecurity industry
Yep.
for years. Is how do we manage those access credentials? What are the best ways to do it?
Mhm.
And we talk about long passwords and we talk about multi-factor authentication, but there's been this more mainstream approach through blockchain tech with the understanding of what does it mean to own and manage a private key, and how does
Right.
that identify yourself, ultimately in this case to the blockchain network.
Yep.
That of course brings up the biggest question, again from a cybersecurity and a threat perspective, which is if I'm given that private key, and maybe before I kept passwords in a password manager, or I wrote it on a piece of paper, or I just
Yep.
remembered my password, I probably can't remember my private key since it's probably about
Absolutely not.
90 characters, all
256-bit.
random,
Yeah.
yeah, all the way through.
Mhm.
You'll never find it, or remember it offhand. So, what are the best practices then to protect that private key? Again, whether it relates to coins or
Yep.
anything else that might be used in the future around blockchain tech.
Yeah, absolutely. I mean, we're familiar with PKI because we've worked with government agencies or other agencies using smart card or PIV card type authentication, and basically that's a carrier for your private key, so to speak, right? So it's like kind of embedded, and there's centralized servers and controls around that. You don't really have that in blockchain, or in this kind of wallet infrastructure that we built around blockchains.
Because
Um,
it's distributed, right? There's no
Right, it's
central
distributed.
authority
So
that I
there's
can like
you
call
don't
back to.
right, exactly. The whole purpose of the movement is that you are self-sovereign. There is no trust, so you do not want to I mean, exchanges, if you go buy a cryptocurrency from an exchange, you're obviously trusting them to hold it for you. And there's this colloquial saying within cryptocurrency: not your keys, not your coins.
Mhm.
So basically, if you are not managing your private key, securing your private key yourself, whoever is actually owns that public address and actually owns your coins. So one of the things that people tend to do is, um, there's a couple things kind of that are kind of like a little bit orthogonal here, but um, when you're generating a wallet to a crypto to a, when you're generating a cryptocurrency wallet, one of the steps in that process is that you will generate the public-private key pair that's associated with that wallet. Usually, if you're using a desktop app, it'll save it in a local file, like a DAT file. So one of the things you're going to want to do, and mostly all of the clients that allow you to generate these wallets will also allow you to encrypt it with a password at generation. So that is like paramount. If you're storing your private key in a .dat file on your computer, you need to encrypt it. You need to use a password to encrypt it when you're creating it. Otherwise, you lose that file. You lose your public key, your address, your wallet. Um, the Actually, that's if I don't know if you remember the Colonial hack and then the retrieval of the ransomware that the FBI pulled off,
Mhm.
the ransomware bounty that the FBI pulled off. One of the theories is that the FBI got access. Well, they had seized a bunch of servers from the hacking group, and then one of the theories is that on one of those servers was the Bitcoin Core client where they generated the wallets, and they found the wallet.dat files, and the hackers either lazily didn't encrypt them with a password, or the FBI was able to crack the password, which
Are you
is
telling me you're not supposed to leave your passwords in clear text on your computer? Is
you
that what you're
well,
saying?
they definitely didn't leave them in clear text probably, but they either
Have you
didn't
only been
encrypt the
saying this
wallet
for
at all.
decades?
Yeah, I know. They either didn't encrypt it at all, or they used weak passwords that the FBI takes their dictionaries and their infinite computing processing power and runs through their guessing programs, and they probably either brute forced it or they cracked it somehow. I don't think it's not too feasible to actually break or crack the password using just a hash or something like that, but it's possible. The FBI might have tools we don't know about. So,
And I think you
yeah.
hit it on the head earlier, right? It's at the end of the
Mhm.
day, you have that private key, you have the
Yeah.
coin. It
Yep.
is much closer to cash in that regard, right? You either are holding a
Exactly.
dollar bill
Yep.
or not. There's no question about it. In the world of digital finance, there's a question about who has money anywhere at any time. So it
It's
is much
yeah.
closer to the real world.
And it's a little risky. It's a little bit riskier than like your bank password, right? If somebody compromises your bank account through your password or your PIN, you have recourse. You can go to your bank and say somebody compromised my account. They can check their logs. They can do some basic forensics and say, okay, yes, they can recredit your account, open an investigation with whatever law enforcement they have to try to get that money back from whoever took it. You don't really have that recourse or that kind of fallback in blockchains, public blockchains, because, like I said, they're basically write once databases. So once you've signed that transaction with that private key, it's essentially authorized and gone, right? So if somebody empties your wallet address, it's gone. Um, short of coercing 51% of the miners to either roll back the chain or reorg the chain or do some sort of fancy trickery. And that's why a lot of people like custodians. That's why people like banks. People like the exchanges in cryptocurrency. They like those things because they don't take on the risk of having to secure their own private keys. Somebody else's. I mean, there's a trade-off there, right? The trust issue. Um, but that's why a
What
lot of
what do you
yeah.
do and what do you prefer? Do you prefer
I self
custodians
custody.
or to do it?
No, well, so I self custody as much as I can, where I have to like. There's really no way to enter the market right now to get a cryptocurrency, even ones for like utility functionality, without going through some centralized custodian right now. They're working on like decentralized on ramps, but it's just not really a thing yet, and there's not a lot of liquidity in those things. So you kind of have to come in through a centralized custodian. So there's that trust. But as soon as you get that cryptocurrency, move it off exchange, move it to an address that you manage the private key for, you own the wallet for, and kind of learn and walk your way through that. There's a lot of instructional materials on the internet that will give you best practices for securing your wallets. The other thing when you're generating a lot of these non-custodial wallets is you'll get either a 12 or 24 word seed phrase, depending on what client you're using. And usually you'll get one because it's the only way you can recover your account if you ever lose your private key. And that is just as important to secure as the private key itself, because you can basically recover the account and the private key from those seed phrases. And
Yeah, well, you
and
see this
so
in passwords all the time, right? With accounts, they'll give
yep,
you your password. You might, or rather, you set your password. You might set up
yep,
multi-factor authentication, but they'll give you those, 10 recovery codes, right?
exactly, yep.
Securing those are just as important because it's
Mhm.
still another door in, it's just an alternate door in case you forget the key to the other door.
Exactly. Yep. And that's it's that's a fallback. So really, like, you should lock those in a safe somewhere. Put them in a vault. Put them in a biometric safe in your house, something that's fireproof and indestructible.
Is this
And that's
something
like the
normal
weirdest thing
people
to say.
have?
It's like,
Just a
right, yeah,
biometric
I just went
bank
out and
vault
get
in
a
their
get a
house? Yeah.
safe. I mean, the other option is, this sounds weird, right? But you can write them down, and as long as you know that you're never going to lose your that little book, or at least write them down in a way that's not immediately distinguishable from looking at them, right? So, like, if you put them down, like, it's 12 words, you put down six in columns, just like it looks like when it feeds you the seeds out of the client or out of the wallet. That's probably going to raise a red flag to somebody who steals it and is like, oh, this looks interesting. Maybe this is the seed phrases. No, like, if you put them in like a small simple cipher, like, you I don't know, go circle words in a book. Go buy Tom and Huck, go buy Huck Finn and circle words in the book. Some sort of little code and codex that you only know. So there's ways to secure that without getting into, like, the nuclear bunker scenarios, but really, those are the things that you have to worry about. And self custody is scary. When you're initiating transactions yourself, signing those transactions, it's scary, because if you don't know what you're doing, you could either accidentally send the wrong amount of funds. You can swap the fee and swap the balance you're trying to transfer, and end up, you know SOL, for lack of a better term. There's not a lot of recovery in these networks, so you have to be very careful with both managing the security of your private keys and your seed phrases, and also how you use them, and making sure that you're using them only in places, um, that you trust. So if you do end up, like, with a wallet on your desktop with a private key, don't go to some website, and the website's asking you to input your private key for your wallet, and it's doesn't have HTTPS in the header, and it's something you don't know, you're not familiar with, there's no reputation for it. Don't give them your private key. Like, this is kind of like the basic stuff we talk about. Don't give your passwords away, but people do it. People fall for things, all the time, and that's kind of just what you have to be aware of. And there's a lot of phishing. There's a lot of phishing attacks in the crypto space. There's a lot of there's a lot of yeah, it's basically phishing, but, like spoofing and impersonation type attacks in crypto space. Then there's the fabled wrench attack in the crypto space, where, some big guy with a wrench comes to your house, knows you have a private key, and tries to coerce you to use your private key, or take it from you. Um, that's the kind of thing you have to think about. So when you're talking to people online, not having some level of OPSEC awareness is also helpful. Not filling people in that you are, hey, I'm this big crypto whale, man. I trade every day. I got all this stuff. I use all the DeFi products. I just bought, like, a bunch of a bunch of CryptoPunks NFTs, and this other guy is like, man, you just have your first name, your last name, where you work in your profile, and your city and location. I'm just going to come to your house and wrench attack you for that. That's the kind of stuff you have to think about.
Well,
It's
it's funny
scary.
because, yeah,
Yeah.
I don't think there is there's a little bit of a barrier to entry, right, to
Yeah.
get into those cryptocurrency markets. But I think you're right. There is a steeper learning curve
Hmm.
to understanding what it means to work in those. And there's definitely more risk, right?
Yep.
Like you said, it's not as easy just setting up a username and a password at your bank.
Yep.
And again, the bank has years of understanding about risk profiles, remediation laws like FDIC to protect your
Yep.
funds and things like that. None of that exists in the crypto space. So there is I think it's probably safe to say that there's a significant amount of risk compared to just traditional banking.
Yeah, absolutely. And I mean, if you want to minimize your trust a little bit with banking, you can at least sometimes, if you have maybe some connections, or your vendor or something like that, you can get a SOC 2 report, or a SOC 1, or some other third party audited, or third party audit attestation report for the controls that they have in place, and kind of see some of that, to give you a little bit more, peace of mind. That doesn't really exist in crypto right now, in blockchain right now. The A lot of the services that are rolling out, it's a lot of move fast and break stuff type scenarios. So both like Ethereum, the smart contract environment is very full of bugs, full of risk, full of vulnerabilities. You'll see what they call rug pulls on a weekly basis, basically, because somebody insecurely coded a smart contract people funded it with millions of dollars worth of cryptocurrency, and then it gets siphoned away by some hacker who exploits it. um, or the wallets that come out, people don't actually do any security audits on them, and there is some backend infrastructure for connected wallets especially, and nobody knows what's going on back there. So like MetaMask is a good example here. MetaMask is a very popular Ethereum wallet that is non-custodial and allows you to interact with what they call Web3 or decentralized applications, by connecting to those applications using Infura as a data provider. So Infura's nodes, Ethereum nodes that they run, are basically your counterparty in every transaction. So when you broadcast transactions, it goes through Infura's node. They can censor, they can do all sorts of things. They can take those nodes offline, which can put you at a disadvantage if you're trying to make a market play, or if you're trying to do something like maybe somebody got your private key and you're trying to do some contingency and move your funds as quickly as possible. If their nodes are down, you can't communicate. So you either have to run your own node, which is, for most people, it's not feasible. It's also not very beneficial because um, most people don't care about trusting the network or not trusting the network. They kind of just go with the flow. But that's the only real like mitigation you have is to run your own node, and something most people won't do. So
Well,
there's a lot of risk.
I think that brings up a good question, really, ultimately about the heart of blockchain,
Yeah,
just technology. Is while on paper, I think it's generally defined or thought of as immutable.
right.
But is that really the case? I mean, noting kind of all of these things that kind of happen,
Yeah.
these rug pulls, forks, as people have taken over, created bad contracts, or even
Yep.
as they maybe try to create their own private blockchains and maybe implement them incorrectly.
Yeah.
Could we call it immutable? Is that a fair thing to say, or is it kind of immutable with an asterisk at the top?
It's definitely an asterisk. If you talk to people in Bitcoin, or maybe even if, well, Ethereum probably not, because they've had an immutability event, I'll call it, in the past with what was called the DAO hack and DAO hard fork. If you talk to Bitcoiners, they'll tell you that basically Bitcoin's immutability is unchanging over time. That's their definition, unchanging over time. So probabilistically, the likelihood of somebody being able to reorganize the blockchain, or censor enough blocks to double spend or do something like that, is close to zero. But the real, the computer science hard definition of immutability is unchanging, unchangeable. Um, and so basically, that's not really a thing. There's a social layer that exists on all public blockchains, where all the parties, all the participants in this big game theoretical mess, can their interests can align, right? So the miners' interests can align with the developers and the community. And if those interests align, then the devs can push code, the miners in the community and the non-mining nodes can run that code, and that can make changes to the network. What that can do is they can censor blocks back, um, as far back as they basically want, if they have all the hash power in agreement and all the full nodes not rejecting those blocks. So in two instances in Bitcoin's history, and a lot of people don't know this, in two instances in Bitcoin's history, in 2010, there was a critical flaw that actually created 184 billion Bitcoin out of thin air. So there was a transaction, and it doubles it was the transaction was, they basically exploited a bug in the code to cause an integer overflow or value overflow, and that resulted in 184 billion Bitcoin being created in two output transactions. And what the Bitcoin community did, Satoshi Nakamoto, and I believe at the time it was like a gentleman named Gavin Andresen, they worked to create fixed code. They fixed the client code. They gave that to the community, and they asked the community, like, hey, can you guys please run this so we can, you know, uh, take these blocks, and what they call it is a reorg. Basically, that just means like the blockchain splits, and then once the longest chain, with the most accumulated proof of work, kind of takes the lead, this other chain just disappears, right? So what they did is they had one chain, they initiated the upgrade, and basically said, okay, go back to this block height, this block number, and at that point, invalidate the block that contained those 184 billion Bitcoin transactions. Invalidated that block and the chain that spawned off of it initially, and created a new chain, a new longer chain underneath. So this chain kind of just fell off. So those blocks were effectively censored out of the blockchain history forever. So that's how they kind of resolved the issue and don't have 184 billion plus potentially 21 million or whatever the supply is in circulation. So that's one way that they did it. In 2013, there was another event where there was an upgrade from Berkeley database as the underlying database for the Bitcoin core client to Level DB, and there was some issues with like block size and locks, and it caused an invalid block to be created, and a consensus split. So the blockchain actually split, where one version of the clients, the upgraded version, went on one side with one block, and the not upgraded clients went on another fork of the chain, and they both kept creating blocks simultaneously, and the fork chain overtook the unupgraded version. And so what they had to do is like they had to halt everything, stop all the merchants from accepting transactions and all the exchanges from processing transactions. They had to push out another soft fork update, which is a backwards compatible update basically. They had to push out another backwards compatible update to basically eject that other fork with the malformed blocks, so that they can continue on with the intended chain. So that's where like the intent of code is actually what drives these things, rather than like code is law. So there have groups of people that say like code is law, it's unchanging, you should never change it. So if that were the case, we'd have 184 billion Bitcoin and a bunch of giant blocks that were created because Berkeley DB's lock specification was wrong. But so there's a social layer atop all these things where the participants can interact, and they can choose whether or not to take action on things. Whether they choose to reorg the blockchain, use their powers, basically exploit that 51% attack weakness to affect good change, like fix things. So there is that social layer. People like to obfuscate that. Unless you're in Bitcoin will obfuscate the value overflow in the Berkeley, but they'll definitely point the finger at Ethereum and say, you guys violated immutability with the DAO hard fork. Even though technically all those transactions exist in Ethereum's ledger still, they used a hard fork, which is a not backwards compatible change, to recover a bunch of funds that were stolen by a hacker. So there's mechanisms, and so every time somebody says that a blockchain is immutable, I kind of like laugh a little bit inside, but at the same time, I understand that they're probably talking about more like probabilistically. So the more blocks you build on a chain, the more unlikely it is to change in the future, or the harder it is also to change in the future. The more blocks you try to reorg back, the more hash rate it takes. You need 51%. You need time to build that new blockchain, and then in that time, those miners are losing basically the money that they would have had on that other chain. So it's a lot of complicated stuff, but they are changeable. Yeah. Short answer.
That is fascinating.
Yeah.
The good news is too, just got in a question I think relates to something that we were talking about earlier.
Sure.
Obviously, we know that the world of passwords needs to come to a close, given that there's this advent of quantum computing. And so I
Yep.
think as we're talking about private keys and obviously PKI infrastructure within the world of IT, ultimately, how does quantum computing maybe impact blockchain specifically and the cryptography around that? Is that a concern or something that blockchain tech is trying to address and get ahead of?
It is. Excuse me. It is in the a little bit longer term. Right now, I don't think there's the qubits available right now for anybody to actually do anything that malicious on a blockchain. It's certainly not break the ECDSA signature. Signature schemes that are in use, but it is a valid concern for the future. So there is a lot of work going into quantum resistant algorithms, and blockchains can be upgraded. So that's one of the things. Like though they may be non-changing over time, not immutable, they may be non-changing over time. You can make changes to add improvements or efficiencies or optimizations, put in new features, as long as you have community buy-in and whatnot. So like Bitcoin just added Taproot, or is about to activate Taproot, and Ethereum adds a new feature every other month, it seems like. It's weird, but yeah, absolutely. The emergence of quantum computing is a risk to blockchains, not immediately, but definitely as that technology progresses. But also at the same time, we've got there's a lot of research crypto researchers building quantum resistant algorithms that hopefully we can use to kind of offset those issues. Um, I don't know that I don't know that quantum will ever fully manifest into its most powerful form like everybody kind of anticipates. I have this feeling that like it'll stick to the corporate the corporate side or the research side as a means of use, but I don't know. We'll see. You're not going to get like a hacker group in I don't know Sweden or something like that running quantum computing rigs and attacking Bitcoin. I don't think, at least not for quite some time.
I was going to say, yeah, I think it'll be
Yeah,
something we're watching closely within the really cybersecurity community at large, and I
yeah.
suppose especially
They
within
gotta
the cryptocurrency space, given the money associated with it.
Once they scale them down and make them a little bit more modular, then we'll have to be absolutely concerned. But
Hmm.
yeah,
Got a feeling that's happening in our lifetime.
probably. I mean, it absolutely will. We'll just it's there's ways to kind of like mitigate. Mhm.
Yeah.
Like
Well,
everything.
hey, we are at the end of our time for today.
Sure,
I want to thank Andrew for joining us and making these complex concepts more approachable. For me, one of the
absolutely.
key takeaways was ultimately thinking about blockchain like any other tech. Oftentimes, it's sold as a silver bullet solution and
Mhm.
that it is perfect, but there's always kind of those idiosyncrasies that make it not work the way that it maybe is sold. So, just something to think
Yep.
about as you get involved or potentially invest in things like cryptocurrencies or explore other blockchain type solutions for your organization.
Yep.
Before we go, make sure to sign up for our next event at www.hivesystems.io/hive live. Next month, we have a very special guest. You're going to enjoy this talk. Make sure to check our page again to sign up and see that. Again, that is at www.hivesystems.io/hive live. Thank you again, Andrew, for being here. I really appreciate it.
You got it. Yeah, absolutely. If does this chat stay open if I put stuff in the announcements, some links or anything like that, or does it close?
It should close out, but for those who attend, we can send out some of those bullets to
Sure.
include some of those items that you mentioned. So we will absolutely do that.
Great.
To everyone watching today, until next time, remember when it comes to cybersecurity, you need to act and not react. Thank you.